So in the last class, we discussed the centripetal force. Centripetal force is the net force towards the center. It is given by mv square by r or mr omega square. Okay, we will discuss one of the example. Okay, one of the example we will discuss. So okay, we will wait for 1 minute because azan is going on. Okay, so first we will discuss what is frequency and what is time period. Okay, we will revise what is frequency and what is time period. So frequency means number of revolution made in 1 second. Number of revolution made in 1 second. For example, if here is a particle, and that particle is moving in a circular path. Okay, that particle is moving with us in a circular path with some angular velocity omega. Here omega is the angular velocity. Now in 1 second, how many times this particle will complete the circle will be the frequency. Okay, number of revolution made in 1 second. Okay, number of revolution made in 1 second is frequency. Unit of frequency is one by second, because frequency is what? Number of revolution per second. Okay, that is why the unit of frequency is 1/second or hertz. Okay, hertz. And there is a relation between the angular velocity of a particle moving in a circular path and the frequency. Angular velocity is equal to 2 pi times of the frequency. Omega is equal to 2 pi f. Omega is equal to 2 pi f. Now there is another term, time period. So time period is the time taken to complete one rotation. So for this particle, okay, for this particle to complete one circle, the time taken will be the time period. So time taken to complete one rotation is time period. Now there is a relation between time period and the angular velocity of the particle. Time period is equal to 2 pi divided by omega. Time period is equal to 2 pi divided by omega. And there is one more relation that is in between the frequency and the time period. F, small f is the frequency, capital T is the time period. Frequency is equal to 1 upon time period. Okay, we will use these relations. Okay, here. Now here I am taking there is a particle. This is a particle of mass m, and this is a string of length L. Okay, this is the string of length L, and this string is attached with this. This is a fixed support. Okay, this is a fixed support. Means this thing is fixed. This thing is fixed, and from this fixed thing, fixed support, an string is attached, and from that string, or you can say a particle is attached or a stone is attached, and this particle is performing the vertical horizontal circular motion. Means this particle is moving like this. This particle is performing the circular motion. Something like this. Okay, particle is moving something like this. So this will be the center. So basically this mass is moving in a circular path like this, and one string is there. Yeah, this is a string. You have to find the time period of revolution, of this mass m. Okay, we have to find the time period. Now how we will find the time period? Okay, time period of revolution of this mass. And now for that we should know what is time period. Time period is the time taken by this mass to complete one circle. Time taken by this mass to complete one circle will be the time period. That we want to find. Okay, now here we will see if this mass is moving in a circular path. This mass is moving in a circular path. For any mass to move in a circular path, there is a requirement of centripetal force. There is a requirement of centripetal force, and that centripetal force is provided by some other force, and that centripetal force is equal to the net force toward the center, is equal to the net force toward the center. So remember, this mass is moving in a circular path. This is the string. This, now we will see what forces are there on the mass m. Okay. First we will see what are the forces on the mass m. So Shafruddin, can you tell me what will be the forces on this mass m?
Centripetal force.
Yes, it centripetal force will be there. Obviously, there will be a centripetal force. Now on this mass m, there will be one weight. There will be weight of the mass. Okay, this mass will have the weight.
Gravitational.
Gravitational forces. Gravitational force is nothing but of the weight. Okay,
Yeah.
weight, and that is, you can say also gravitational force. Okay, due to the earth there will be the gravitational force, and that gravitational force will be mass into gravitational acceleration, mg. Okay,
And
Basically,
so
yeah.
for gravity, is there's a constant value, right?
Yeah, actually, no, for the gravity is not constant. If you will see on Earth we assume that uh, on Earth we assume that the gravity is constant. That is 9.8.
Yeah.
Approximately, we assume that on Earth it is 9.8, and when you will go to the moon, that value will be 1/6 of 9.8. Okay, so on moon the value of the gravity will decrease. But if you see precisely on Earth also, if you will see precisely on Earth also, the value is not constant. That means in actual the value will not always be 9.8. Means if you are going on a hill that is at very high altitude, there the gravity will be less. Okay, the value of the gravity will be less. But for solving the questions, for solving the numerical, generally we take the gravity as 9.8, that is constant. But gravity cannot be constant. Okay, it changes. Okay, it changes. If you are on the Earth, the value of the gravity, okay, will be something else, and when you are some suppose on some other planet like on Mars, the value will be something different. So gravity changes with the planet to planet and position to position, the gravity changes. But for solving the numerical, for certain height or for certain distances, we take the value of the gravity as constant, that is 9.8. Okay, otherwise precisely if you will see, the value of the gravity will change with height or with depth. That thing, this thing we will study in the next chapter. In the gravitation we will study, and we will see the value of this gravitational acceleration will change with height. Okay, so I think you got your answer. Now the gravitational force mg will be vertically downward. So this is vertically downward on this mass. Now there will be one more force, that will be the tension in the string. There will be the tension in the string also. There will be the tension in the string also. This is a string. So I told you in a string there will be tension, and there will be tension force. Okay. And this string has the length of L. So there are two this time. One force on mass m is in this direction, that is tension force, and one force is in the vertically downward direction. Okay, so here now what we will do, we will take a step. What we will do now, I am drawing a line like this, and I am drawing a line toward the center like this. Now this, see this angle, this angle, this angle I assume theta. Okay, this angle, suppose this angle is theta. This angle is theta. So if, and this line, okay, this line and this line are parallel lines. So if this angle is theta, so you can say this angle will be theta. This angle will also be theta. These are vertically opposite, not vertically opposite, alternate angles. If this line parallel, okay, this line and this line is parallel, and this is another line. If this angle will be theta, this angle will also be theta. Now this is the tension force. Now this tension force is acting. This tension force is making an angle theta with vertical. Now what we can do, we can take the component of this tension force in the vector. In the chapter vector, we discussed that for a force we can take component. For example, if suppose a force is like this, a force is acting in this direction like this, Suppose uh, this is a force F, and this force is making an angle of theta with this direction. Okay, and this direction and this line and this line are perpendicular. So you can just break this force along this line and along this line. So you can write the component of the force, the component of this force, or you can say the effect of this force along this axis will be F cos theta, and along this axis will be F sin theta. If suppose here tension is given, instead of force it is tension given. So instead of force you will write T cos theta and T sin theta. T cos theta and T sin theta. Okay. Now this is tension force. You can just break this tension force along this and along this. Okay. So now in this direction, the component of the tension force. First calculate the component of the tension force in this direction. This is T. Along this direction, the component of the tension force will be T cos theta. And in this direction, it will be T sin theta. Now this particle or mass m is moving in a horizontal circle like this. Means this particle is moving in a circular path. For motion in a circular path, there is a requirement of centripetal force, and that centripetal force will be the net force toward the center. So toward this is the center. This is the center. Now toward the center, what is the force? T sin theta. T sin theta is the force toward the center now. Okay, now we will not use this T. Instead, we will use T sin theta and T cos theta. So centripetal force, okay, centripetal force is equal to T sin theta. And what is the formula for the centripetal force? You can just assume this distance as you can just calculate this distance. Okay, this distance you can calculate. So suppose this is point A, and suppose this is point B, and this is point C. Okay, I have taken this triangle and I want this distance. I want this distance, BC distance I want. And this distance is given as L, and this distance is theta. This distance is theta. Now, if this distance is theta and this angle is 90 degree, this angle will be 90 degree. This angle will be 90 degree. So opposite to 90 degree, there is hypotenuse, and opposite to this angle theta, there is the altitude of the triangle. There is the altitude of the triangle. AC will be the base of the triangle. We can apply the trigonometry here. So we can apply the trigonometry. So this distance you can find, BC distance you can find by cos theta. Find first sin theta. So from this triangle, sin theta will be this BC divided by L. Altitude of the triangle, perpendicular of the triangle divided by the hypotenuse. BC divided by L. Now you can get BC, that will be equal to L sin theta. Okay. Now this distance you have, means this distance you have L sin theta. Now what is the formula of the centripetal force? Mr omega square. Mr omega square. or mv square by r or mr omega square. So mr omega square is equal to t sine theta. Now instead of r, this will be the r. R is the what was the r there in the centripetal force? R was the, you can see here. This was the r, na? This mass is rotating. So this distance will be r. Okay. So r will be this distance. Okay. Distance between this mass and the center. So this is r. So r here will be L sine theta. So you can put value. Okay. So first assume this as equation number 1. Okay, first assume this as equation number 1. Now this t cos theta will be equal to mg because there is no motion in the vertical direction. No motion in the vertical direction. Okay. No motion vertically. No motion vertically. No motion vertically. So if there is no motion vertically, means this force, means net force towards this direction will be 0. Net force towards this direction will be 0 on this mass m. If this mass m is not moving along the vertical direction, okay, because this mass is moving like this, not like this. So net force on the mass towards the vertical direction will be 0. You can say t cos theta minus mg is equal to 0. Okay. Net force towards y direction is equal to 0. You can take this direction as x direction, this direction as y direction. So net force towards y direction is equal to 0, means t cos theta minus mg is equal to 0. So you can write mg is equal to t cos theta. This is equation number 2. Now divide equation 1 by second. Divide equation 1 by second. So what is the equation 1? Mr omega square is equal to t sine theta. This is divided by mg by t cos theta. So it is mr omega square divided by mg is equal to t sine theta divided by t cos theta. Divided by t cos theta. Now from here m and m will be cancelled out. T and t will be cancelled out. Okay. T and t will be cancelled out. So you have r omega square divided by g, and that is equal to sine theta divided by cos theta. Now what is the value of r? What is the value of r? Here this r is equal to L cos theta, L sine theta. Okay. This is the value of r. So now put the value of r here. R is L sine theta multiplied by omega square divided by g is equal to sine theta divided by cos theta. Now this sine theta and this sine theta will be cancelled out. So you have L omega square by g. L omega square divided by g is equal to 1 by cos theta. Now from here you can find omega. Okay, you can find omega. So from here it will be L omega square cos theta is equal to g. So omega square is equal to g divided by L cos theta. Omega square is equal to g divided by L cos theta. Now from here you can find omega. So omega will become g divided by under root of L cos theta. Now there is a relation between the angular velocity and the time period. There is a relation between the angular velocity and time period. What is that? Omega is equal to 2 pi divided by t. Now time period will be 2 pi by omega. Okay. Time period will be 2 pi by omega, and we have to find the time period. The time period will be 2 pi by omega. Okay. So when you will write 1 by omega, so it will become L cos theta divided by G. It will become L cos theta divided by G. So finally the time period will be 2 pi under root of L cos theta divided by G. So this is the time period you will get. So here now we have used the concept of the centripetal force to prove this. We have used the concept of the centripetal force. What I used here, the net force toward the center, will be the centripetal force. Okay, this Fc is the centripetal force, and that is net force, that is equal to net force toward the center. So net force toward the center here is T sine theta, and rest of the things is just the vector and math and calculation. Understanding, Shafdin?
Yes.
Okay. We will do this question for revision. Because we will use all these things when we will start the gravitation. All these things will be required, the centripetal force, the concept of angular velocity, all these things. Shafuddin, please try to solve this question by yourself. Just try. I will solve. Okay. And this question is from your book. Try it. First read the question properly on the and take the pen and paper and try to solve it. Try to apply your mind, and actually you should have your notes also, because here there will be a use of frequency and time period. Otherwise, how will you solve? For this question, the concept of the frequency will be used. I am telling you what is frequency. Frequency is number of revolution made in 1 second. In 1 second, the number of revolution made is frequency. Almost each and every question of your book we have solved already. Each and every concept deeply we have studied. If you are not getting the answer, we will solve it, no problem. But at least you should try this. Okay, I am solving now. Okay, now see the question. I am solving. Very good question. This is a very good question, I will say. A stone attached to a string. A stone attached to a string is moving in a horizontal circle. Is moving in a horizontal circle of radius 90 centimeter. The stone has a mass of 65 gram and completes one revolution in 0.70 seconds. Calculate the tension in the string. Okay, calculate the tension in the string, keeping the stone in the circular path. So basically, what is the question? The question is, uh, there is a string and there is a stone. This is the stone and this is a string. And they are saying this stone means this string with a stone is moving in a circle. Okay, in a circular path. So can draw the figure like this. So basically, this is the stone and this is a string, and this string is rotating in a horizontal circle, not in a vertical circle, in the horizontal circle, like this. Okay, this is a this like this mass is moving in a horizontal circle. This stone is also moving in a horizontal circle of radius 90 centimeter. Radius means this distance is 90 centimeter length of the string. So this is 90 centimeter. So 90 centimeter means 0.90 meter. Okay. So radius is given as 0.90 meter. We have converted the centimeter into meter. After that, they are saying the stone has a mass of 65 grams. So this stone has a mass of 65 grams. 65 grams. Okay. Now we can convert the gram into kilogram also. So in 1 gram, in 1 kilogram, there are 1000 grams. So we can convert 65 grams. It will become 65 into 10 to the power minus 3 gram. Okay. Because in 1 kg, there kilogram. Oh, it will be kg, not gram. It will be kilogram. So we have converted the grams into kilogram because kilogram is the SI unit, and we have converted the centimeter into meter. Okay. After that, they are saying the stone has a mass of 65 gram and completes one revolution in 0.7 second. In 0.7 second, 0.70 second, it is completed one revolution. Now from this, now we will get the frequency. How we will get the frequency? It is given in this time, in 0.70 second. This mass is completing one revolution. In 0.70 second, there will be one revolution. Now, what is frequency? Frequency is number of revolution in 1 second. In 1 second, how many revolution will be there? Will be the frequency. Now we can calculate that in 1 second. In 1 second, the revolution will be 1 by 0.70 revolution, and this value will be the frequency, because in 1 second the number of revolution will be frequency. So this will be the frequency. So we have now frequency that is equal to 1 divided by 0.70, and you can remove point, here will be 100, so it will be 10 by 7 hertz. So frequency we have 10 by 7 hertz, because unit of frequency is hertz or second inverse. We have this frequency. They are saying calculate the tension in the string keeping the stone in the circular path. Tension in the stone. Now there will be some tension in the stone. Here there will be some tension in the stone. T will be the tension. Okay, with respect to the stone, this tension force will be towards the center. Now tension we will calculate with the concept of the centripetal force. Now, what is centripetal force? Because this stone is moving in a circular path, and for the motion in a circular path, there is a requirement of centripetal force, and that centripetal force will be the net force towards the center. And what is the net force towards the center? Tension force. So, net force towards center is equal to the centripetal force. Centripetal force. So net force towards the center is tension force, and what will be the centripetal force? What is the centripetal force? You can find that will be mr omega square. Centripetal force, we have mr omega square. Now there is one relation between omega and the frequency. Omega is equal to 2 pi into f. 2 pi into f. From here, from this frequency we can find angular velocity. So it will be 2 pi into frequency, that is 10 by 7, Now we can use 2 into the value of pi is 22 by 7 we can put, and it will be 10 by 7. Okay, so basically it will be 440, 22 to the 44, 10 the 440 divided by 49 radian per second will be the angular velocity. Now we have angular velocity, we have radius, we have mass, we can find the tension force. What is mass? Mass is 64. You can see the mass 65 into 10 to the power minus 3 kg. It is 65 into 10 to the power minus 3 kg. The radius is 0.90 meter. Omega square means 440 by 49 square. Okay, 440 by 49 square. Shafruddin, please calculate this with the calculator. This value.
Yeah. Yeah. Okay.
Okay.
-4.316 multiplied by 10 to the power of -3.
What is the answer? Point
4.316.
4.316.
Yeah.
4.1.
No, 4.316
Okay,
multiplied.
just a minute, just a minute. 4.316 multiplied by
10 to the power of -3.
10 to the power of -3. Okay. So what will be the unit of tension? Because tension is also a force, so unit will be Newton. So unit will be Newton. So we have done, basically we were discussing this chapter. Just a minute. It is on page number. Okay, so we will see this chapter from the starting from your book, and almost all the topics we have covered. So this was a motion in a circle. So we have discussed radian measurement and angular measurement. Means they are talking about the angular acceleration. So initially we have done this. We have done angular speed also, and after that I have solved this example. I solved this example in the class. This example also we have solved in the class. After that, we have the centripetal acceleration and centripetal force. So I told you what is the centripetal acceleration, and I told you the whole topic, means what are the types of acceleration. So in that there is one centripetal acceleration and centripetal force. Centripetal force we are discussing. So basically this is the centripetal force and centripetal acceleration. You can see we have discussed this in detail. Okay, after that centripetal acceleration is this, centripetal force is this, and we have done all the question. These all the question we have solved already. These questions also we have solved. This question right now I have solved. You can see a stone is attached to a string and moving in a horizontal circle, radius 90 centimeter. The stone has a mass of 65 gram. Okay. So now example of the circular motion. Uh, Here you can see we will discuss this also. Motion in a vertical circle. We have done now. I have shown this image also to you. We have done the vertical circle, so we will revise this also. Okay, motion in a vertical circle, and after motion in a vertical circle we have done this questions also. Okay, I have not done this question. I have not solved this question. We will solve this question also. After this chapter is finished. So basically I have taken this question in the class. I have taken this question also in the class. This fourth question I have not taken in the class. We will solve that. Okay, so this is the first question. So in the first question, see, uh, this is the first question. They are saying how state how the centripetal force is provided in the following example. Okay, state how the centripetal force is provided in the following examples. A planet orbiting the sun. Shafuddin, tell me what will the answer of this question? I told you this in detail. First part, A, answer A. That what type of force will provide the centripetal force to a planet that is revolving around the sun?
Gravitation.
Hmm?
Gravitation.
Yeah, very good. Gravitation force. So answer will be gravitation force. A planet orbiting around the sun is gravitation. Very good. Second, a child on a playground round uh, roundabout. So there is a child on the playground. Okay, and that child is on something and that is rotating in a circular path. Okay, so in this case what means, which thing will provide the centripetal force?
Is it
Hmm?
circular? No.
No, actually
Frictional force.
hmm? Friction force.
Friction.
Okay. Actually, in this case, a child on the playground roundabout, and you have seen that on the playground there are roundabouts. So in this case, I think the centripetal force. We know that centripetal force will be the net force over the center. So the weight of the child will not provide the centripetal force. So in this case, the centripetal force is provided by the, you can say that the tension in the rods of that. Okay, provided by the tensions in the rod of the roundabouts. Okay, that will be the tension force. Now in this case, a train on a curved track, a train on a curved track, a train is moving on a curved track. So in this case, what is the source of the centripetal force? Obviously in this case, the friction force between the wheels of the train and the track will provide the necessary centripetal force. Okay, and answer number D, a passenger in a car going round a corner. Obviously in this case also the friction force. Okay, in this case also the friction force will provide the necessary centripetal force. I told you that whenever we are in a car, so actually in this case now, in the second case, so there can be the two sources. There can be the two sources. We discussed that. I told you that banking of roads also, from one side the road is lifted, so there the normal reaction as well as the friction force provide the necessary centripetal force. Okay, but in the case of the train on a curved track, there will be only friction force between the wheel of the train and the track, that is providing the necessary centripetal force. But in this case, there can be the two sources. First is the, if the road is banked, then in that case normal reaction as well as there will be the friction force between the tires of the car and the road. So friction force as well as the centripetal friction force as well as the normal reaction will provide the necessary centripetal force. So we have discussed these things already here. You can see here each and every topic I have covered. Okay, even we have done these questions all also. Okay, turning of a car on a curved road. So here which is providing the centripetal force? Friction force. You can see here. Okay, friction force is providing the necessary centripetal force. I think I have done the banking of road also. Banking of roads means road is lifted from one of the side. So here you can see normal reaction is providing this normal reaction. The component of the normal reaction is providing the necessary centripetal force. Okay. So we have covered all the things, but we will revise it. Then we will understand it properly in a proper manner. So last question, we have to solve this question number 4. We will solve this. Any doubt or any question if you want to ask regarding this chapter? Because in the next class, first I will discuss these concepts. Means first we will revise these turning of a car and all that. Okay, then we will revise the uh, vertical circular motion, and after this we will start the next chapter, that is gravitation. Next chapter will be the gravitation. You can see here we were doing this motion in a circle, and after that we will have the gravitational fields, means the gravitation. Okay, Shafuddin. So you have notes, these notes? Means at that time you took the screenshots, na?
I haven't taken it.
Hmm?
I didn't take the last few, like the last 3.
No, I am not talking of today. Means earlier we have done these topics, na?
Yeah,
So
that I have.
so you have those notes, na? So at
Yeah,
least,
yeah.
na, before coming to the next class, na? So just once, for once, see the notes. Okay, see and the notes from here. I'm telling you from where. This topic is finished. You can see the notes from here. After this topic, I have told you the centripetal force. I have told you what is friction force, what is the normal reaction force. So we'll discuss that in the next class. And these topics are there. Okay, a person is moving uh, on the surface of a bell. So what will happen? What will the surface speed and all that? After that, I discussed one more topic, centrifugal force. There.
Yeah.
Okay, so you have to just see these things. Okay, and in your notes, turning of a car on a curved road, you should see this also. This I have done with the help of the centrifugal force. I told you that that time we can do this with the help of the centripetal force also. Okay, but when we do with the centrifugal force, it for the feeling purpose it is better. It uh, gives you more feel of the force. So we will now. Which chapter is going on in your right now in your school? This chapter now,
We finished chapter
gravitational
one.
field.
Yeah, done.
Gravitational field completed or going on?
It's over, sir.
So which chapter is going on now?
Chapter 17.
Chapter 17
17.
means electric field.
No, it's, I'll tell you the topic on screen. It says,
Hmm?
I'll send you the topic.
Yeah, please send me the name of the chapter, okay? Uh, please send me the name of the chapter that is going on. Okay, otherwise there will be problem. Uh, Send me the name of the chapter, okay? Which chapter is going on? Then accordingly we will start the chapter. Okay, Shafuddin. So after this class, please send me the name of the chapter which is going on in your school. And apart from this motion in a circle, apart from this, which chapter from A1 level is